Welcome back, everybody. We're going to do another assembly session today, which means I'm going to learn assembly, code assembly, play around with assembly on camera without cutting, without scripting, without even necessarily teaching you something. It's more like I'm teaching myself, I'm learning myself and keeping the camera going and commenting on what I'm doing, but not with a focus on teaching, more with the focus on learning, and maybe I say some stuff on the side. I don't know if you guys enjoyed the first episode because I recorded it yesterday from my perspective, and I'm already doing the next session today just because I want to keep learning assembly today, and I thought I'm going to record it. So you're probably going to see this even if you didn't like the first episode, so if it didn't get a lot of traction, let's say. But yeah, I probably, if you're seeing this right now, published the last episode a week ago or something like a week ago, and I'm doing the second one already the day after. So as a quick recap, we're not going to spend too much time recapping, but last time I built this addition, or I coded this addition in assembly. Not the most optimal script, I guess, but we had a buffer for the input. We had two buffers for number one, number two. We had a flag to control first and second. And basically, we read from standard input. We read from standard input. We had a register for the result. Then we just went character by character and basically subtracted 48, which is the code for 0, for the character 0. And by doing that, until we encounter something that is not a number, not a digit, we basically continue to do that. Then we jump to done. The first time we saved into number 1, the second time we saved into number 2, and then we just exited with the result, which of course was modulo 256, which is, yeah, suboptimal, but it was more like an exercise. So today I have actually some ideas. I have an ideas markdown file here of a couple of things that I could try to implement because I asked ChatGPT essentially what are some easy beginner level assembly projects that I could try to do. And it came up with a couple of things, and I wrote down 4 of them. So I think string reversal is an interesting one, which is more like a lead code problem in assembly. So I don't know if I want to do that, but I wrote it down because I think it's not extremely difficult and it could be interesting to implement. Bubble sort, same thing, same idea, just an algorithm, and try to do it in assembly. A little bit more interesting is the bootloader. Now, you cannot think about a bootloader in terms of an actual bootloader, so not something that will actually boot into the kernel and stuff like that. But I saw that it's probably not too difficult to just have something that runs on the raw hardware. So the BIOS sends the computer to the bootloader, and then it displays Hello World or something. And then also trying to actually get it to a disk and to actually boot it in a virtual machine. I don't know if this is possible, if this is easy to do, but this is something I would like to look into. And then I thought also an XOR Cipher, which basically the idea of an XOR Cipher is you have some message, let's say hello world, and each of these characters has a byte, or each of these characters is a byte. And a byte is basically 8 bits. So even though this is not going to be correct now for hello world, it would look something like this. That would be one character, or maybe if you want to write it as a byte, that would be one character. That could be another character. That could be another character, and so on. So basically, you always have these 8 bits. And then what we would do is we would have an XOR mask. So we would have something like this, for example. And XORing that would result in something. So in this case, it would result in 0, 0, 0, 0, 1, 1, 1, 1, and so on. And I think if you then do it back, you get the original thing. So 1, 1 is 0, 1, 0 is 1, 1, 1 is 0. That's basically the idea. So that's a symmetric key for encryption. Maybe we can do that in assembly. And I think actually I'm going to start with this. So I'm going to try to do an XOR cipher myself. Of course, I'm going to Google, I'm going to use ChatGPT, but not to get the solution immediately. I'm going to try to do it myself. The idea being user inputs stuff into stdin. We apply an XOR mask. We print result to std out. And of course, it works the other way around. The user can take what we print and feed it into stdin, same mask, and then we get the clear text. That is the idea. this is what I would like to build. So let's actually start a file called XOR Cipher.assembly. Let's do the usual stuff section. Text is the most important one. We're going to have start, as always, the entry point, global start. And we're going to say start like this. All right. What do we need? We need an input buffer because the user will input something. Let's limit it to 32 bytes, 32 characters. So section BSS input buffer resb 32. Well, buffer 32 bytes. And the user feeds in some string, 32 bytes, and we're trying to... By the way, I have a shirt here that is beautiful. I use Arch, by the way, if you didn't know. Yeah, so the user feeds in 32 bytes. Now, we need to have a static XOR mask, let's say. And for this, I think we can just use the data section. I'm not sure about this. I'm also not sure how do we take 32 bytes, because the idea, of course, has to be the key needs to be of the same size as the input, unless, of course, you want to repeat the key. That's also a possibility. So if I have something like this as input and my key is this, let's say, then what I can do is I can just repeat the key all the time. But yeah, that's of course easier to crack. So let's see. Let's say that my key is equal to, and now which data type do we choose for 32 bytes? In assembly, in the data section, which key do I choose for 32 bytes? Not key, which data type? By the way, my voice, as always, has some problems. I do have some chronic stuff with my nose and throat and so on, which is why I basically, for already 5 months, sound like I'm sick. Yeah, so you need to get used to that occasionally. So that is 8 bytes. Since I need 32 bytes, that is... what is this? I actually do care about initialization. I do want to define the I want to hard code the key into the code. So what is this here? dub0. db, I can reserve 32 bytes because that is just a single byte, as we know already. And that is 32. What is this dup? I mean, probably it's 0 initialized. Duplicate the value. Okay, so okay, that's the same thing as saying db and then 0, 0, 0, 0. Okay. Good to know. I'm going to comment this out. Is same as key db, let's say 32 .0. Just so we know that. New piece of information. So the thing is, I don't want to have 0. So actually, I won't even use that. I need to decide on a key. Okay, so can I do key db and then a string? My fancy key that has, or whatever. Can I do that? So, null terminator. As far as I understand it, I don't need a null terminator in assembly if I know that it's going to be 32 bytes. So I just need to find some key that is 32 characters. So let's see, let's just write something that will have probably close to 32 characters. My fancy key for this cipher in assembly. I guess this is going to be probably 33. There you go. So one too much. Yeah, let's just remove the Y. It's the easiest thing we can do. All right, so that is my key now. This is my fancy password, and or actually maybe we can do assembly, and then instead of this, we're going to do the. So that should be 32 now. There you go. All right. I think it should not be too difficult to do this now, because all I need to do is I need to load the buffer. The problem is I will probably need to use 2 registers, because as far as I understand it, a register has 8 bytes. 8 bytes is 64-bit, yes. So I need to probably do something like RAX and RBX are considered to be 1. So I load one part into RAX, one part into RBX, and then I do just XOR. This should not be too difficult, at least in my head right now. It makes sense. So what if I move? Of course, I need to do std in first. So I need to do, we need the codes again. Assembly syscall codes. So needed to mute myself briefly for the cuffing. So let's go here again. We had std in, reading from std in was syscall 0. I'm actually just interested in the registers here. So we move into REX 0. We move into RDI 0. We move into RSI, the input buffer, and we move into RDX 32. Not sure if this is a problem if I do it like this, but I think this should work. Syscall, this is our std in. And now I have this in the input buffer. What I would like to do is I would like to move into RAX. Now, how do I do that? How do I move 8 bytes from my, or actually, no, sorry. We have 8 bytes per register. So I need 4 registers. Or I need to do it 4 times because I cannot load 32 bytes into a register. I don't have a register of that size. Probably there's an intelligent way to do this in assembly. I'm just going to use the knowledge I already have, which is not a lot, to try to do this myself. And then I'm going to ask ChatGPT if there's a more reasonable way to do it. So my idea is, let's boot up Excalidraw again. Still have the same stuff from yesterday. Can I clear this somehow? How can I start a new project? Can I start a new project somehow? Not sure. What I definitely can do is I can just select and remove everything. Not sure if that is the only thing I can do, but yeah, doesn't matter. So yeah, my idea is we have now an input buffer. Let's just use different numbers for the sake of simplicity here. I'm, of course, working with 32 and 8, but let's say I only have registers with 2 bytes, and I have an input of 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8. So now I have 8 bytes, and I have registers of 2 bytes. What I would have to do is, if I have here A, B, C, D, E, F, G, H, I would want to start with some bytes and load them here. Let's say these 2 bytes into register A, for example. Let's say this is RAX. We know it's 8, but let's say it's 2. And then I would like to perform the same thing. I have the key as well, and I want to load the first characters. If I have a key of size 8 as well, my key, whatever. Then, of course, I want to load into another register. I want to load into RBX, for example. I want to load MY. And then I want to do an XOR operation and store the result, let's say, in RAX. RAX has the resulting thing, whatever that is. And I think I need to have a results buffer. So I'm going to allocate 32 for the result buffer. So basically I just take that and move it into the result buffer. That makes sense. So I just need to have a pointer, which could be RSI. It's already pointing to input buffer. So how do I do that? How do I load 8 bytes? There was I think keyword is the right thing, right? Keyword assembly. What is a keyword? 64-bit value. That's 8 bytes. Yes. Okay, so if I'm not mistaken, all I have to do is I have to load the first 8 bytes from input buffer into REX. So I need to say keyword res, or not res, rel. But do I need rel? Let me see. In assembly, when do I use rel for addresses? Emit a RIP relative relocation instead of an absolute one. You need it whenever you want to reference a symbol via the instruction pointer, which is especially important for accessing data in 64-bit mode. Generates an absolute relocation, only supports relative loads. So NASM will complain or give you a large. Okay, so I guess I'm going to ask it again to explain that later on, probably, but let's say rel input buffer keyword. That should load 8 bytes. So if I'm pointing right now to the first byte, it should load 8 bytes. And the same thing, I guess, I can do for key. I'm not sure if I have a syntax error because the highlighting is different. Probably, I don't know. Yeah, let's just keep it like this for now. But basically, I should be loading now 8 bytes from each. And then I can just do XOR of these two. And then I should be able to load a keyword into result buffer, of course, with rel again, from REX. That should work for 8 bytes. So in my opinion, if I just change this, or let's not change this, but I think this should, not sure if this should work, but what if I now say move into REX, move into REX 1, move into RDI 1, move into RSI result buffer, move into RDX 8 syscall, and then move into RAX 60, move into RDI 0 syscall. So that is std out, writing to std out, and that is exiting with code 0. Not sure if this will even assemble. Let's see. So XOR, okay, works. Linker XOR Cipher .o XOR Cipher. Let's do something simple. Let's say I have hello world or something. It doesn't print anything. It would be nice now to see. Okay, let me take a look at my code. So this confuses me a little bit because I think that usually when one keyword is highlighted like this and one is not, there's some problem. So let me see. Let's keep it simple and just do 8 for now. In this case now, this should be perfectly fine. But also let's see what happens. Let's open up an ASCII table, because I also want to see what happens when I actually do that. So my key is, of course, now I need to change this 1, 2, 3, 4, 5, 6, 7, 8. Comment out the rest. So my fancy key, like this, translates to the following bytes: 109. Actually, I think we can do this easily just for checking in Python. So if I have key is equal to my fancy K, and then I have message is equal to hello were, like this, then I should be able to do this. No, okay. Then let me briefly see in Python, how can I XOR two strings? I actually did this. I even did this in a video, I think. I don't want to research this now. Yeah, but I don't want to specify the bytes. Okay, I need to encode them. Okay. So let's say key B is equal to key.encode. But of course, we want to encode in ASCII, not in UTF-8. And same thing for message B is message encode. And now bytes. What is that? Okay, so let's say bytes X or Y for X, Y in zip key B, message B, or actually, yeah, doesn't matter. It's commutative. Okay, and can I take this now and decode it as ASCII? Okay, or do I have to... These are the raw bytes. Hex would be cool. Okay, but can I not render these bytes somehow? Can I render the bytes in Python so I don't see the bytecodes, but the representation? Yeah, I don't want to see the hex. I don't know why you don't understand this. I don't want to see the bytes. I want, for example, \n to be rendered as new line. Or maybe to not confuse them too much. Yeah, decode should do that, but it doesn't do that. But this prints I want to render this. Oh, is this maybe because I'm not printing? Oh, there you go. Okay, I need to print this. But cool, so that's basically what I get, so I wouldn't even know. That's a bit, okay, so... Okay, other thing. When I run something on Linux, how can I get std out as hex code? XXD. So basically, if I take that... okay, I don't have this now. Let me try to do XOR again. But I'm gonna pipe this to XXD. And I'm gonna say hello W. Okay, I don't think I understand what's happening here. That is what I get as an output here. So let me try something else. If I specify a bunch of, I mean, 0 is not 0. I know it's 48, but interesting. So maybe let's try something else. Let's try to provide something here for my message. So what should be the output if I say message is equal to a bunch of zeros? So actually, how many characters do we have here? 8, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. And we have the message B encoding, and then I have my printing here. Okay. It works, actually. At least for the most part. It only prints 1, 2, 3, 4, 5, 6. Because SK is not part of this anymore, I think. But maybe that's also a problem with XXD. But I'm not sure. I don't know what XXD is even about. Create a hexadecimal representation from a binary file or vice versa. Hex dump. Interesting. What is this SK I see when using XXD? Can I somehow... What if I say .hex? And what if I do this here again? So here my message was, actually 0, 0, 0, sorry. 0, 0, 0, 0, 0, 0. Okay. 5D, 49, 56, 51, 5E, 53, 49, 5B. Okay, works. The printing is a different problem, of course. You're not going to get this. I'm not going to do B64 encoding in assembly. You can forget that. I'm going to work with the hex codes here. The question is now, can I do this with 32 bytes? So if I do this with 32 bytes, I need to do it multiple times. Four times, to be precise. This should be quite simple, I think. If I say XOR loop move into RCX 4, So I basically decrease, I have 3. I decrease, I have 2. I decrease, I have 1. I decrease, I have 0. 4 times, yes. So I do this once. Then I decrease RCX. I also need to adjust the pointer. So the pointer that's pointing to input buffer. Or does this make sense? Wait a second. Because I'm not using a pointer here. I'm using rel. I need to say... Now the brute force solution would be to use, let's say, move into... I think I can use RDX. I could say 0. No. Probably it makes more sense to use something like a pointer. So maybe let's say RSI pointing to input buffer. And then basically I need to say, I don't know if that's how you do it, but can I just add to RSI 8? Not sure if this is how it works. But my idea then is to say, okay, test RCX, jump if not 0 to XOR loop. And otherwise we're done. Not sure. But in my world, this could make sense. It assembles, it links. Command not found. I mean, of course. But let me just see. There's a problem in... Why do I only get this much? Okay, let me ask ChatGPT something. In assembly, when I point to a buffer that has 32 bytes by doing move RSI input buffer, how can I shift this pointer by 8 bytes to the right? Oh, I don't use move, I use the effective address calculation. Good point. So I actually say LEA but I don't want to do +8. I want to do plus whatever we have. LEA is fine for initialization. But can I not shift the current position by 8? Question mark. I mean, I can. Actually, it tells me to do whatever. It tells me to do what I already did. Not sure if this changes something. Oh, no, wait. If I move, I think I should not be using square brackets. because then I'm dereferencing and going to the actual value. Still. There's something I'm not understanding correctly. Let's go step by step again. I have an input buffer, I have a result buffer. I have my key, which is 32 bytes long. I start by getting 32 bytes of input into input buffer. This should work. Then I say I have a counter for, I'm loading the input buffer address to RSI. I'm saying move, oh, of course. Wait a second. I should not be doing that. I should be using RSI. So actually, and I need to do the same thing for the key actually as well. So maybe I can use RDI for the key. So I say rax RSI, RBX RDI, and then I need also something pointing to the result buffer. So what are register names in assembly? Because I know that there are other registers as well. We have, they're not listed here, but we have something like R8 or whatever they're called. Why are they not listed here? Yeah, these ones. R8, okay. So move into R8. Actually, I should do that in the beginning. R8 should be pointing to the result buffer. And then I can just say move into R8 rax. And then I don't just add to RSI, I add to RDI and to R8. This could work. It doesn't work. Okay. It doesn't work. I'm pointing to the beginning of input buffer, to the beginning of key, to the beginning of result buffer. That here, in my opinion, from my understanding that I have right now, which is quite limited, this should take the first 8 bytes from input buffer and load them into RAX. This should take the first 8 bytes from key and load them in RBX. This should result in an XOR in RAX, and this should take that XOR result from RAX and store it into R8, which is pointing to... Does it work like this? We did that already yesterday, I think. Pointing to input buffer. We're getting the value. Yeah, I need to get the value. Not sure if I do need to do it here. But let's see if that works. No. I think I'm not quite understanding the assignment in these square brackets. This means take the value that RDA is pointing to. RDA is a pointer to input buffer. So just like my addition example from last time. Input buffer is the buffer. RDI is pointing to that input buffer. Here I'm taking the value and I'm storing it here. Now what am I doing here? I'm pointing to the input buffer. Actually, I don't need to do this again, I think. But yeah, let's keep it for now. I'm taking the value from the input buffer and storing it in REX is what I would think. I'm not sure if this is problematic. Let me just try, even though I don't know why this should be the case. No, actually, this doesn't make sense. If anything makes sense, it would be that. But I don't think that. I don't think this makes sense. It does. Okay. So basically... Okay, so I think if I do move R8, RAX, I am saving the value of RAX as an address into R8. By doing move R8, RAX, I save what is in RAX into the address or memory location that R8 is pointing to. Got it. I'll probably make this mistake a couple of times because you can see how I learn stuff. I don't learn stuff by following some guide and learning stuff how you're supposed to do it. I usually do trial and error until it works, and then I try to understand, to reverse engineer why it worked. But yeah, let's see if this is now reasonable. Let's go into Python again and say my key. Where's my key? My fancy. Let's go into my code here. Let's copy this. And in Python, I'm going to say now my fancy key for the cipher in assembly. And then I'm going to say that my message is going to be equal to a bunch of zeros. And then I'm going to do what I did before. I'm going to encode the key. I'm going to encode the message. I'm going to do the XOR. And okay, nice. And then I'm going to try also to see what the hex code looks like, because that's easier to follow. And now I'm going to try to do the same thing. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. I get the exact same output, and I get the exact same hex code. Ladies and gentlemen, we implemented an XOR cipher in assembly. Perfect. Cool. So this works. I would still like to know, I think I had a question. Did I have a question? I'm not sure. But one thing that I would like to know is if this could be done way easier. So I'm going to ask ChatGPT. I implemented an XOR cipher in assembly. It works. But could this be done more easily and professionally? And probably I shouldn't use O4 for this, but yeah. Okay, so this uses a calculation for the key. That's fine, but in this case, I think this doesn't matter really. Input buffer, okay, makes sense. This is just some numbers. some aliases, let's say. Okay, so increment basically shifts 8 bytes. Or no, okay, this is doing it bit by bit. Byte by byte, sorry. Okay, but this is actually kind of stupid now because it says here easier to read and understand and juggling 64-bit chunks unless you need the speed. So would you say my solution is faster in terms of performance? Cool. Yeah, then shut up. Awesome. Cool. So let us try the other thing, which I think is more interesting. I'm not sure if this is even a project that I should attempt, but I'm going to ask ChatGPT. How realistic is it to code a simple, minimal bootloader in assembly as a beginner? Ambitious, but certainly doable with the right mindset. Thank you very much. Wow. Okay, on PCs, the BIOS initially loads your first sector at address and jumps to it in 16-bit real mode. You'll be writing instructions that manipulate segment registers, work with 16-bit registers, and use BIOS interrupts for screen output. Size constraint. Exactly 512 bytes, including the boot signature in the final 2 bytes. Every instruction and data byte counts. You often optimize for size and turn to macros or self-modifying tricks. Hardware interaction. You're talking directly to video memory, disk I/O ports, BIOS routines. No OS abstractions. This is cool. Must know NASM syntax. I think we know that to some degree now. Understand 16-bit registers. Yeah, you basically just you don't use RAX or EAX, you use AX, BX, so you use the last 16 bits, which is the last 4 bytes. Then we use interrupt with code. Is this 10? I think this is not 10, this is 16, right? Or am I understanding this wrong now? I think it's 16 because you have 0 times 1, 1 times 16. For text output, and this for disk reads. How to assemble using a debugger like GDB. Cool. This looks a little bit more ambitious, so I'm not sure if I'm going to be able to do that today. I think I'm going to try, and in the worst case, I'm just going to let it do it for me, and I'm going to try to understand what it did. So let's ask some questions. Help me understand what a bootloader actually is and how we even get into it from the boot up or BIOS. When you press the power button on your PC, a lot happens before your familiar operating system, definitely not Windows, ever shows up. The bootloader is a tiny piece of code whose job is to bridge the gap between your firmware, BIOS, and UEFI, if this is how it's pronounced, and a full-blown OS. So, the CPU holds itself in reset until the power supply signals it's stable. Okay. On older PCs, the BIOS runs its built-in code. On newer systems, the firmware takes over. Performs a post power on self-test. Checks RAM, CPU, GPU, disks, etc. Finding the boot device, boot order. Okay, this is all still in the BIOS. This is not something that we need to care about. Let's say it finds my hard drive. And then what happens is first stage bootloader. Master boot record. On a BIOS boot disk, the very first sector, 0 to 512 bytes, is reserved for the master boot record. The firmware reads that sector into memory at physical address this and jumps there. What's in those bytes? The stage 1 bootloader, minimal code to locate and load a larger stage 2 from disk, a partition table, and a boot signature, a magic value that tells BIOS this is valid boot code. Okay, cool. From stage 1 to stage 2. Okay, this is already quite crazy. I don't want to actually boot into an OS kernel. I don't want to build an actual bootloader. I would just like to get to the point where these 512 bytes are executed and I can print hello world to the screen without using a syscall because I don't have an OS, of course. Now, my goal is to actually build a simple bootloader that is automatically started by the BIOS and then prints hello world without any OS underneath it. And that's it. Is this something I can do as a beginner in assembly? Because I don't know how comprehensive this is. Okay, this provides the code. I don't want to look at that, but let's see what it says before that. You can definitely pull this off as a first project. Okay, we fit this into this size. Running it in 16-bit, we understood that already. Assemble emulator. Okay. Let's say I have this ready and implemented. Can I also test this bootloader in a virtual box? Okay, cool. So without providing me with the full code, I want to do this myself. How would I even approach this at all? How do I start? Okay, I already have this. I don't care about the emulator. I don't care about the editor. Okay, I don't care about this. I meant more like a template for the code. Incremental developmental step. Okay, so I think I will need to let it show me. I meant in terms of code. How do I get started? What are the first couple of lines? Okay, this is way too much. Just 1 or 2 lines. Okay, so I basically specify with bit 16 that I'm using 16-bit real mode. So assembly bits command. all x86 instructions. I don't see a bits command. Am I understanding something wrong, or? Okay, so a couple of questions. Why can I not find bits in the list of x86 instructions? Also, what does org do? Why do I not specify 0x0000, but the end? They are assembler directives, not CPU instructions. Okay. Okay, so this is basically something that tells NASM what to do, not the CPU what to do. Okay, so it doesn't execute that, it just tells NASM this is 16-bit code. And this sets the origin. In a BIOS boot scenario, the firmware reads your by saying every label and data reference in your code is assembled as if it lives at that offset. I don't think I understand that. You don't declare segment register here. What happens? But why the offset? I thought my code will live. I thought my code will live between 0 and 0x000 and 0x7c00. Is this wrong? Okay, so this is a different syntax. This does not mean from 2, it means it loads it here with an offset of this. Okay, so does 0x000 0x7c00 mean that or not mean from 2 but add and offset? I know this is not a proper English sentence. Okay. Then I need to figure out why 7c. So if I get this correct, we have 16 to the power of 2, 16 to the power of 3. That would be 96 times 7 plus 256 times 12. Y0x7c. I mean, probably this is just a convention. I don't know. Probably there's no logic to it. Simply a leg. Okay, cool. I don't need to understand this then. So, instruct NASM to assemble to 16-bit real mode, whatever real mode means. But basically, I said now origin Stat legacy convention also written as this. Cool. Then it says, after that, I define start. Okay. Okay, so after these two lines, what do I do? Again, just 1, 2 lines. I think it's more like understanding how to build one than actually building one myself, because I think this is a bit too much. So why do we call this? Why can we just say start and don't need to define section, text, global, start, etc.? Okay, so we have no linker. We're gonna write some stuff down here. No linker, because makes sense, because we don't produce ELF64 code or formatted binary. We assemble into raw 512 byte blob. Cool. Because of that, we start with a simple start. Now, you never went through a linker that needs section or global. Let me write this down as well. Because of this, we don't need section and global, etc. So this is moving something here for whatever reason. Offset of your null terminated string. Okay. Now, without providing the code itself, tell me what the steps are I need to implement here. Just conceptually. Okay. Tell the assembler your environment. We did that already. Set up segment registers. Ensure DS and ES, if needed, point at your code data so your pointers resolve correctly. We need to understand what DS and ES is. Point to your string. Load an index register, for example SI, with the offset of your 0 terminated message. Read a byte. Test for 0, call bias to output it, increment pointer, and repeat. Once you hit the terminator, disable interrupts, halt the CPU, pad with zeros up to byte 510, then write the 2-byte boot signature. Okay, this is the stuff that makes it an actually valid code. So I have a couple of questions. One, what is DS and ES? 2, what is SI? 3, what is 0x10, 0x0e? Probably some syscall to the bias. 4, is int in this context similar to a syscall to the OS just for the bias? 5, why do I need to do CLI and HLT? And then the rest is clear. I understood that. Okay, so DS and ES are actually, let me take a look here. x86 registers again, because I think I should actually, no, I don't understand that, because I do have, okay, these are segment registers. These are different. We have general registers and we have segment registers, and then we have index and pointers. I need to understand the difference here. Okay, segment registers. In 16-bit real mode, each memory access uses a segment offset pair. So the default segment used for most data accesses, extra segment, default segment used for most data access. I don't quite understand what this means. Second data segment, often used by string or block moves. You typically set them so that your code and data buffers live in the same 64 kilobyte window. I'm not sure I understand this. Source index register. When you do string or byte operations, SI holds the offset within DS of the next byte to read. Okay, so that basically, does this then hold the initial address and this then holds the offset and it's increased? I'm not sure. Okay. I think I need to understand something first. What is the difference between general registers, segment registers, and index registers? Are these just conventions, or are they actually different in terms of functionality? Each of which can also be accessed as different registers. Okay, primary use, hold operands for logic, loops, counters, function return values, and so on. Flexibility, you can do a lot of stuff with that. Okay, segment registers that form the high half of a segment offset address in real and protected mode. Primary use, define the base of code data stack or extra segments. Implicitly or explicitly, anytime you reference memory. Instruction fetches use CSIP, data loads. Okay, I think I'm missing a lot of basic knowledge here that is required to understand this. Less flexible, you can't do arithmetic directly on segment registers. Okay, changing them requires special instructions and may trigger a hidden descriptor table lookup in protected mode. I find this super interesting, really. I think this low-level programming stuff, it's difficult, and I'm not really competent at it, but I really enjoy doing it. I just don't know if I want to spend too much time with this, because I don't know if this is super relevant to my career, so to say, but I think it will make you inevitably a way better programmer. So I think you're not wasting your time if you learn assembly, even if you never code in assembly. But yeah, I think this is super fascinating. So index registers with instruct, the CPU uses SI implicitly as pointers into, okay, this is stuff I don't really understand here. In a nutshell, fully flexible for all sorts of things. Segment registers define where in memory different categories of data and code live. You can't treat them like normal data registers. index registers, dual row, general purpose, and the implicit pointers for string memory instructions. Okay, now that we know that sort of, so what does DSSI mean for my message? Nginx, interesting choice. When you see an instruction that implicitly or explicitly references this, it simply means holds the upper part of the address multiplied by 16 to get the physical segment base, holds the offset from the, okay, that's actually what I thought. This is like here, essentially. Okay, so back to our step-by-step plan. We told the assembler about the environment. We need to ensure now that DS point at your code data, so your pointers point to your string, load an index register with the offset. Okay, so to the first step. I need to use DS and SI to point to my string hello world. Without providing the code, how do I do this conceptually? The message does not exist yet. Remember that after the BIOS jump, your code and data both live in the same 64 kilobyte window starting at this. Okay, you need the data segment to cover that window. So you load into DS whatever segment value makes DS times 16 be that. In practice, that means copying the segment, the code segment value, the BIOS set into DS. Okay, so it seems like, this is the wrong page. It seems like there's a code segment, holds the code segment in which your program runs. So basically that should be set. Okay, CS is the code segment register. The BIOS should set this to 0x7C00. We need to load into DS. Now I'm not sure I understood exactly because, okay, wait a second. Why do I need to load into DS something that needs to be multiplied by 16? In real mode, every memory access uses a segment offset pair and the CPU does the multiplication for you. Shifted left 4 bytes. So the physical address is the segment shifted 4 bytes plus offset. But why is this done? Okay, so you have more address space. Not sure I understand this, but okay, let's just take this, let's just accept this. Due to some stuff I don't quite understand yet, DS needs to hold an address value that multiplied by 16, so shifted by 4 bytes, results in 0x7c00. We can do this by setting ds to 0x0, 7c0, I think. Is this what he said? Yes. Or by just copying cs to ds, I think. Please don't judge me if this is not correct. I'm still learning. So, I point that to the code segment. So let's just say move ds cs. And let's say alternative move ds 0x07c0. Load the string's offset. Your message label lives some bytes after the start of that window. You compute its offset. Assembler will know message is at runtime. But I don't understand you say your message label lives some bytes after the start. Why? I never defined a message. How do I know what to choose as an offset? You don't pick a magic number for the offset yourself. Instead, you'll let the assembler do it for you. Conceptually, the flow is you reserve space for your message. Somewhere after your code, you'll eventually write message is equal to reserve byte hello world, and so on. At assembly time, okay. So basically I need, but do I do this in a data section, or where do I define message? Okay, I do this just somewhere else. So I say message, and I say db. I'm not sure if I can just say hello world like this. I'm not sure if I need a null terminating byte. Let's just do it like this. And then essentially what I do is I say I load into this the message as an offset. So if I get this correctly, it was the tell the assembler your environment, set up the segment register, point to your string, print loop. So read a byte. If I understand this correctly, this means I define a waypoint print loop. And I then say I'm pointing to the string, read a byte. Okay, where do I need to load the byte I want to print before doing int 0x10? What is this? Okay, so there seems to be lot SB assembly. Load string. Okay, that seems to be super simple, and also advances SI. Okay, so probably I need a null terminating string just to know when to stop. But essentially, I think I can just do load string, so LODSB. So what is move AH0x0E4? High byte of the AX register. Okay. When you execute this in the BIOS, the BIOS looks at the AH to decide which video function to run. Okay, this is just a syscall, basically, like a syscall to the BIOS. Okay, so I think if I do this and I then do this, which is just a call, and then I call this, then I need to check if... how do I do that? How do I check now if the byte I'm pointing to is 0? Can I do test and then DSSI, DSSI, jump if not 0 to print loop? Can I do that? I'm just going to leave it like this and then ask it if I did any mistakes. But if I understand this correctly now, once I did that, I do a clean exit. Not sure if I just have to do CLI, HLT. Okay, how do I properly call CLI and HLT? Okay, I just call them. And how do I pad the remaining bytes? Okay, cool. So that basically, actually I don't need to do this in uppercase, times 510. I need to understand the syntax later on. I'm just gonna copy it for now. DB0, boot signature. Okay, so I write now 0xAA55. So this is my current code. Would this work, or are there mistakes? You're almost there, but there are a few small corrections. Loading DS. You can't move DSCS directly. Must be done in 2 stacks via the stack. Okay, so I can push CS onto the stack and then pop it into DS. Okay, so let's just do it like this then. Okay, I have a question though. Would this work though? No, I have to work with... Okay, you can't load a register directly from an immediate... Okay. In real mode, we cannot load directly into segment registers. We need to use the stack. So what we do is we push CS and we pop DS. Then I would like to know, why does this work? Or does it not? But why can I use move here and don't have to use the stack. There is an opcode. Okay, I need to write this down. We can do this though, because there is an opcode for load a general purpose. I don't understand the difference. Oh, SI is a general purpose register. That is why it works. Okay, we can do this though, because SI is not a segment register. Opcode exists. Opcode does not exist. Okay. Cool. So what else did he say? Testing for the end of string after the byte you care about is already in AL, so you should test that, not test the entire thing. Makes sense because we're only testing a single byte, so I'm not testing this actually. I'm testing... Why is it an AL though? Okay, I need to ask the question here. Regarding point 2, is my testing wrong, so it does not work, or is it just not optimal? Actually incorrect, okay. Okay, so we're already pointing to the next one. Got it. So probably this is something I don't understand here. That this ends up in the A register. So lot SB, let me write this down. Lot SB loads next character into AL and increases SI. So I need to check if that is 0. Good. Loop structure. A more typical loop looks like this. If 0, jump to done. Okay, so this is correct. What I don't understand is regarding point 3. You are testing right after LODSB and you jump Oh, makes sense. Wait. Yeah, because you're loading and you want to see, is the character I just loaded, is this 0? If it is 0, you want to jump to... Yeah, makes sense. Okay, I'm going to adjust this. Done. Then you want to jump to done. Otherwise, you want to move and call the instruction. and jump always to the print loop at the end here. And if we go to done, we get to CLI, which I don't know again what it does. Then we halt. Okay, what I don't understand, why do you define halt and do halt, jump, halt? After your last meaningful instruction, you don't want execution to fall through into your data or padding bytes, which would just run garbage opcodes and likely crash. Rehalt after any stray interrupt. Even though you did CLI to disable, you could still wake up the CPU. Okay, so we just want to have an endless loop for halting just in case. Okay, understand. Okay, so let me just copy paste this again and see if this is... So is this implementation now correct? Will it work? Almost there. Okay. There are two showstoppers. Good. Okay, that's just a syntax stuff. That's just a syntax error. MSG is defined after your padding and signatures, so it lives outside the 512. Okay, your code will try to read. Whereas I points to bytes that were never loaded, you'll get gibberish or a crash. What you need to adjust is you need to do the message before the padding. So can I just do this? Would this be correct now? Almost. Okay, small typo. You accidentally concatenated. Oh, I mispressed something. Is this correct now? Yes, that looks like a valid 512 bias loadable Hello World bootloader. You've gotten the right order as long as you assemble. Okay, so that would be interesting now to see if this actually works. So I assemble now with format bin bootloader.asm -o bootloader.bin. It assembles. So let's take a look at bootloader.bin. I should not be able to read this. There you go. I can only read the string. And if I do object dump -d bootloader bin, I should be able... Okay, it doesn't recognize the format. Interesting. Cool. Awesome. Now I want to run this in VirtualBox. Explain all steps. So I should have VirtualBox installed. I don't have VirtualBox installed. That's not a problem. Sudo pacman-s VirtualBox. Okay, let me just see which is the correct one for Arch. Okay, so I guess 2 is the correct one. Or actually... Okay, I'm just going to go with the default. Okay, so what I do now is I use dd to create an empty floppy image. Then I write my boot file into that floppy image. And then I'll load that into the VM. It would be really cool if this works. And then maybe next time we can try to boot into the Linux kernel or something. That would be super cool. Alright, so let's see if I have VirtualBox now. Yeah, looks like it. Perfect. And now we're going to do what we were told. So I'm going to use dd. What is dd again? This is the thing that you use in the command line to create images. Okay, so dd input file is going to be def0, which is nothing. So we create just an empty thing. Output file is going to be equal to floppy.image. BS is probably byte size is 512. And we're going to use 2880 sectors, whatever that means. Okay, so I should have now the floppy image. There you go. And now I'm going to say the input file is the bootloader image. And I'm going to load it to this floppy file. And I'm not sure what this means. We're just going to write into the first sector, I guess. So conf equal to not run C. No such file or directory. That is not true, is it? Bootloader bin, sorry. Not image. Cool. So now we have an image. And now I should be able to create a virtual box. So I'm going to open up now VirtualBox. Let me just open this here in what do I have to do here? Name your VM. I'm going to open up a new VirtualBox. This is some graphics issue I have here, but it doesn't matter for now. So let's go and follow the instructions. Create new, name your VM bootloader test or something. Okay, bootloader test. Then I want to choose DOS. Okay, this is interesting. I mean, I guess it doesn't matter. I can use this for DOS or I can use this for something else. So I basically use that. I provide base memory. I can go with 16 megabytes is more than enough. I'm going to use 32. That's fine. Disk size, I don't need that much disk size. So let's go with maybe 100 megabytes. There you go. And finish. So oh, I created a hard disk. Did I create a hard disk? Not sure if I created a hard disk right now. So let me just try this again. Other DOS. I mean, it asked for disk size. I'm not sure if this is what ChatGPT meant. But now I should be able to say settings, storage. Let me just briefly. So what I'm going to do now is I'm going to go to controller floppy, choose a disk file. I think this is choose a floppy disk. Yeah, I'm just going to open this on my second screen so I don't have to censor out stuff if there is some sensitive information. So I'm going to go to documents, programming, learning, assembly, floppy image. There you go. So I basically clicked on this button and then on choose a disk file, and then I selected the floppy disk image. And now make sure it's the only or first boot device. Settings, system, motherboard, boot order, floppy. Cool. Let's see if this works. Terminated. Okay. VirtualBox Linux kernel drivers either not loaded or not set up correctly. I'm not sure now if this is... I think this might be an Arch problem. This might be a problem with my system. Yeah, so... yeah, let's just go with this. So I think this was just an Arch thing. And load the modules. Once the right modules are installed, load the VirtualBox driver. Restart the service. Okay, I don't have secure boot, so that should not be a problem. Install some NVIDIA stuff right now. So this is not really a problem with not really a problem with our code. But let's see. But this is awesome, man. I really enjoy coding in assembly. Especially if it works. If it doesn't work, I hate it. Take some time, take some time. So what is this mod probe thing? I've used it a couple of times. TLDR, mod probe. What is the goal of this tool? Add or remove modules from the Linux kernel. Okay. So basically if I do this, okay, it works. And then I can also load this. Not found. Okay, let's just... which one didn't work? This one. Okay. Let's just ignore this for now. Let's restart the VirtualBox service. Doesn't exist, okay. Not sure if this is what I wanted to do right now. I don't think so. What is the VBox web service? I don't know. Let's try VirtualBox again. Let's try to start this. Critical error has occurred. Let me try this again. Critical error has occurred while running the virtual machine and the machine execution has been stopped. Go to VirtualBox VM's bootloader test logs. Okay. VirtualBox VM's bootloader test logs. Now, before I try to troubleshoot this too much, let me just copy paste this into ChatGPT to see if maybe the problem is not related to our code. I'm gonna even switch to O3 for this. It crashes and I see this log. Is this because of my system or my bootloader? Oh, this is too long. I didn't know it was that long. Okay, so let me then maybe just take an example. Where is the arrow? I don't know. Maybe I can look for error. I don't have too many errors, so let me change that. This is very long, actually. Okay. It crashes and produces a log file when I search for error. I see these, but I'm not sure if this is actually why it crashes. Yeah, let's just give it a try. Maybe I have to look for critical. No. Red herrings, they're printed every time. For one sector bootloader, the only thing that will make a VirtualBox crash is a triple fault. The CPU hit an invalid instruction. Okay, do I have a triple fault? I get default. Triple fault. Okay, seems like there is something with triple. Triple fault, but I'm not sure if that is... I don't want to have fault, I want to have this fault. The guest never left. Okay, so I don't think I have triple fault. No. I don't see that. Image really... Is the image really that size? Let's see. Yes. Is the signature really proper? Xdump boot bin tail. Oh, not boot. Bootloader. Yes. That should be a valid bootloader, I think. Easier debugging. QEMO plus GDB first. So, what does this do? QEMO. Let's give it a try. Not found. Probably I have to install this. So what's happening now? I need to go to assembly again, or I'm not sure if I need to go there, but I need to say GDB. I don't have GDB, are you kidding? Arch Linux GDB. Okay. Sudo pacman GDB. So the question is, should this already print hello world? I actually don't, I mean, can I not just do this? No, okay. When I run with Q emo, should I not see hello world? In the little VGA. I don't see a VGA. Or what is this? Let me switch to 04 mini again. This, or actually this is my keyboard interrupt, so let me just copy this. This is what I get. Where should I see hello world? There is nothing else that opens up. Okay, so I can basically try to connect with VNC viewer, which I don't have installed, of course. So let's do that. Probably that's an Arch package as well. No, it's not. So VNC viewer Arch. Is this part of some package or? Tiger VNC. Okay. Where's my VNC viewer? There you go. What was the thing? Localhost or localhost 5900. Hello world, there you go. We booted from floppy disk and we got a hello world. We built a bootloader. Now I'm not sure why it didn't work in VirtualBox. I don't really care because that's a VirtualBox problem. I'm not learning VirtualBox today. This works. This booted from floppy disk and showed hello world. This is a program without an OS behind it, just with a BIOS, and it printed hello world. This is awesome. The question is, how do I get rid of this now? Because I cannot exit for some reason. This is not too nice. So let me open up my btop. Let me try to kill this process. Okay. But that's awesome. Okay, so we got this. Let me see if I can somehow open this with GTK as well. Display GTK. GTK is not available. Okay. What about SDL? Not available. Oh, I can also try with curses. That would be cool. Invalid option. Okay. It says no display GTK. But I'm happy, man. We created a Hello World bootloader in assembly. Now the next question would be, how do I redirect this to a Linux kernel? I have no idea if this is more difficult. I also think that I should stop the recording soon. That is actually a cool thing to have, so I'm going to install this. I'm going to uninstall VirtualBox. But oh, actually, this is the wrong terminal. There you go. Now we have it. Hello world. Okay, I think it just captures my mouse. I cannot do anything. Okay, I think I'm actually... Okay, I need to Google on my phone now how I can break out of this, because I cannot even go. I cannot do anything right now. Control C doesn't work, Control D doesn't work, Control Z doesn't work. Alt F4 doesn't work. How do I get out of this here? I cannot even switch my focus. This is crazy. I'm completely captured in QEMU. Control A, then X. No, it doesn't work. Control A and X doesn't work. Or do I have to do it at the same time? No. This is not cool, man. Okay, wait, I found something. Oh boy, I thought I had to restart my computer. This is scary. This is scarier than Vim when you use it for the first time. But cool. So I have a final question here for ChatGPT. Let's say I wanted to just boot directly into the Linux kernel. Would this be much more complicated? No, not from BIOS. Boot directly into the Linux kernel from my bootloader instead of printing hello world. Big leap beyond a 512 byte print hello world bootloader. Okay, seems a bit more complicated. Let's recap briefly what we did. Bootloader.asm. It's actually not a lot of code. The interesting thing is this here, and also I didn't quite understand, I mean I did understand it, but I already forgot what it did exactly. This just is an instruction, loads the print character instruction. Yeah, that's basically it. Alright, so I think we're gonna end it here. We did an XOR Cipher today. We coded a simple bootloader. We executed it. Last thing I need to do here is I need to remove pacman-rs virtual box. Absolutely everything about VirtualBox needs to be removed. The question is with the mod probe stuff, if I want to completely remove VirtualBox, how do I reverse the mod probe commands? Okay, we can omit the first one. The other ones are also not found. That's good. Okay, cool. So, yeah, that's it. I hope you enjoyed it. Let me know again. Probably you already let me know last time, but let me know again in the comment section if you like these sorts of stream-like dev sessions where I just learn stuff, try to learn stuff. and play around with stuff. I'm probably gonna do more assembly and probably also at some point gonna do C, C++, a bit more advanced C because I know the basics of C, or I have built stuff with C that probably goes beyond the basics, but C, C++, probably Rust maybe. I also would like to look into stuff like OCaml or Haskell, something that's like more functional programming. That would be cool. And yeah. So again, let me know in the comment section and see you next time.